SPM 2018 paper 2. Two particles P and Q move along a straight line such that the displacement of the particle from the fixed point O is S. Particle P start moving from A with the displacement of SP equals to 10 plus 8t minus 8t squared. At the same time, particle Q start moving from point B. The equation of displacement given for particle Q is 6t squared minus 9t minus 12. You are having the initial displacement. For the particle P, the initial displacement is 10. For the particle Q, the initial displacement is negative 12. Usually, initial displacement is 0, right? Because it hasn't moved yet. But for this condition, you have the initial displacement. Why? Because they don't start moving from point O. This is the starting point. I draw somewhere here. Or where is P actually? At the left hand side or the right hand side of O?
Right.
Right hand side, because the initial displacement is 10, right? So can you imagine that starting from O, you got the distance here, which is 10, right? Here, barulah point A. And this is the starting point for the particle P. Okay? And then if you refer to the second displacement there, you got initial displacement of negative 12. So which means your point B will be somewhere at the left hand side. 12 unit at the left hand side of point O. Okay, now let us look at the questions. What is the distance between A and B?
22.
22. We just have to plus them. 10 plus 12, it will give you 22. So 1 mark for the working, 1 mark for the answer. You are advised to find out all the equations first, because for sure you are going to apply all equations in different kind of condition later on. Now let us look at question B. Find the time in the second when the particle met each other. Initially, particle Q is moving to the left. Then after that, it turned back to the right. The P initially is moving to the right because of the initial velocity of 8 positive value. Then after that, it turned to the left. The P and Q, they meet somewhere here. When they meet, they are having same value of displacement from O. We are going to apply the concept of same displacement. Compare. That's it. 10 plus 8t minus 8t squared equals to 6t squared minus 9t minus 12. We make it into general form and then we factorize it. And then we get 2 times here. One is negative 11 over 14 and the other one is 2 seconds. Of course, the time cannot be negative, so we reject. So here, we know that the time is 2 seconds. Okay, how to know where they meet? We put the value of 2 inside the equation. 10 plus 8 times 2 minus 8 times 2 square. We can get the initial displacement of negative 6. They will meet at somewhere at the left hand side of O with a distance of 6 meters from point O. So 1 mark will be given when you apply the concept of same displacement. When you factorize it, you have 1 mark and 1 more mark for your final answer, which is the time equals to 2 seconds. Question C. Calculate the total distance traveled by the particle P when both particles met each other. So to understand the total distance, you got 2 methods here. Of course, first is a graph, second is the diagram. So first method, we are looking at the graph method. P having the initial velocity of 8. So your graph will start drawing from the 8. And then you can see the gradient is negative 16, right? So negative 16 means the graph is going down, right? And it's a straight line starting from the 8 moving down linearly. So in order to find the area, we need to know the time when the particle stop and turn to the left hand side. So when the particle stop, we let the velocity equal to 0, and then 8 minus 16t equals to 0. It will give you the time of 1 over 2 seconds. At first, the particle is moving to the right, slowing down until the half second. Then it will stop and turn to the left hand side. and then it speed up again until 2 seconds, then they will meet each other. You can see two triangles here. We substitute the 0 until 1 over 2 inside the equation for the displacement to find. Then after that, we find the second area, which is from 1 over 2 until 2 seconds. And that will give you negative 18. To get the total distance, we just have to plus them without the negative. Then you will get 20 meters. If you look at this diagram, do you notice that we can actually find the total distance in the easier way because of linear? The area is triangle. 1 over 2 times base times height. If you want to find the area of triangle, we need to know first what is this point, right? We substitute the 2 inside the equations. So you will get negative 24, which is this point. 1 over 2 times 1 over 2 times 8 for the first triangle. 1 over 2 times 3 over 2 the base, and 24 is the height. And you plus them, you will also get 20 meters. So 1 mark will be given when you apply the concept of velocity equals to 0 in order to find the time when the particle stop. So 1 over 2 seconds will give you the second mark. The third mark will be given either you manage to substitute the 0 to 1 over 2 or 1 over 2 to 2 to find the displacement, or here. So after you find both and then you plus them to get the total distance, it will give you 4th mark, and 1 more mark will be your final answer, 20 meters. If you are finding triangle, same thing also, the first 2 mark will be given when you manage to get the time is 1 over 2. Finding the first triangle area or finding the second triangle area, it will give you the 3rd mark. Find both area and plus them together will give you the 4th mark. And 5th mark will be your final answer, 20 meters. Now I want to show you the second method. This one is based on the graph. Second method, we have to draw the motion of the particle. We draw the point O first, and you must keep in mind, particle P doesn't start from point O. It starts from point A, which is 10 meters from point O. So point A is somewhere here. So our P start from here. So that's why I label there 0 second. The particle P will start moving to the right hand side until 1 over 2 seconds. Then it will stop and turn to the left hand side. So our first step is we want to know what is the displacement when the time is 1 over 2. So what we do, we substitute the 1 over 2 inside the equation of displacement. 10 plus 8 times 1 over 2 minus 8 times 1 over 2 square, and then we get 12. This 12 here is the displacement from the point O, right? Not from point A. The initial displacement, which is 10 meters. If the displacement is 12 from point O, means the particle P only moved 2 meters from point A until half second, then it stopped. After that, the particle will start moving to the left hand side. They will meet each other at 2 seconds. So now we substitute the 2 inside, and then we find out that the displacement will be -6. Both particles are staying at the left hand side of the point O, which is 6 meters from the point O. So can you imagine the movement is moving to the left until certain part, then stop here. That is the 2 seconds. So when the particle move back to and pass through the starting point, it will pass through 12 meters again, right? Then from point O, move until 2 seconds, it will travel the distance of 6 meters again. Total distance travel, of course, is not included the initial displacement. So which is 2 plus 6 plus 12, not included the 10 that I highlight there. So that will give us 20 meters. So the first 2 marks will be given when you find the 1 over 2 seconds. 1 mark will be given either you get the displacement of 12 or the displacement of -6 by substituting 1 over 2 or 2 inside. 1 mark when you plus the 2 and 12 and 6 together, and one more mark for you to get the final answer here.